I'm here today at the DevOps Talk Conference, and I'm here with Stephen from Sumo Logic. Stephen, tell me about Sumo Logic.
Oh, well, it's an amazing journey. Sumo Logic is the company which does machine data analytics as a service, as a SaaS service. We're a big player in the DevOps space, and we're really excited to be here today.
Now, I see that you're a sponsor, and so you have a booth here, and I've seen a ton of people over there. Are these all your customers?
So some of them are our customers, yes, and hopefully we meet a few new prospects as well. But it's been, it's been a good day.
Yeah, how have you found the conference content so far?
Content's been amazing. Really glad we're participating in, and we really look forward. We've got an ability through our solution to reduce that mean time to identify issues and reduce the mean time to repair as well by 50%. So it's quite exciting for the DevOps space.
Yeah, absolutely. Thinking about that time to remediate, time to detect, all of that is super important when we talk about DevOps and automation.
Exactly, exactly.
Good stuff.
Yep.
All right.
Microphone check. Can you hear me? All right. Excellent. So, my name is Mike Berry. That's my name. Let me start by giving you context for who I am. The context that's important today is not so much do I enjoy walks along the beach, but it's what I've been doing in the context of my work. So in 2016, 2 years ago, I had a little team we were called the Pitcrew. If anyone here familiar with Scaled Agile and you have a systems team with part of Scaled Agile, that's kind of what this was based on. And we helped the other parts of our development cycle go faster. That was successful, so in 2017 we had a slightly larger team. And they said we need to do more things and we need more things to go faster. And this time I got to choose the name, so I chose Velocity Engineering. That's cool, right? And so that was our team. And then next year later, we're like, this is actually going pretty well in this area. Maybe we should expand this, we should do this bigger and better. And they still had me, so it's bigger at least, maybe not better. Omnichannel platform was born. And so the idea is that omnichannel is a way to refer to all the ways for our customers to come into the bank. And so if you're a consumer that uses internet our services, you may be using our mobile, or you may be using internet banking, or you may be going on our website, or maybe even going into a branch. All those ways to come into us are our channels, and I help run the platform team, which means that we are, some would say a DevOps team, but I would not say that because DevOps is not a team. I would say a platform team, and we help look after various platforms and do things like continuous integration, continuous delivery. But today, in particular, we're talking about Kubernetes. I hope you picked up on that, because there's Kubernetes all over this talk and on my t-shirt. So, back in October 2016, we're thinking, do you know what we should do? We should do Docker in production, because Kubernetes was out there, wasn't that big though. So let's do Docker in production, because we think this will be great. And then we started talking about requirements, and we had a look at a few different ways to do that. So we thought, wow, yeah, we could do Rancher. It was big at the time. We had a look at Rancher. We had a look at Docker Data Center. Sorry, John, that was a bit bad. But then we also looked at OpenShift, and we decided, let's go with OpenShift. And one of the reasons for that is actually OpenShift is kind of like a Red Hat branded version of Kubernetes. And so if you want to do things with OpenShift and do things with Kubernetes, it's kind of the same thing, but Red Hat gives you a few extra bells and whistles to that. And then if you go look at the code base right now for Kubernetes, number one company, Google, is putting lots of commits into Kubernetes. Number two company is actually Red Hat, and so they have some experience there, been working on it. So we go through this, we talk about it, and then we go live in October last year. And so for a large organization, and when I say large, we're about, 30,000 plus people in the ANZ, and our IT is kind of like 6,000 or 7,000 people, so it's a lot of people to try and figure out what's going on, and a lot of, sadly, bureaucracy to get through. So 1 year from I'm thinking about this idea to actually it's running in production, it actually works, customers are making use of this, that's pretty good. And then since then, we've been doing more and more with it, it's getting bigger and better. And now even our business care about it, so they're asking us about it now. So you know when your business are asking you about your technology, it must be doing something worthwhile. So this talk today is our story of what we did with Kubernetes. In particular, it's about 8 lessons that we learned throughout this process to help us there. So some of these are important things to think about, some of these are technical things that you need to understand, and other of these are just good ideas that you could apply anywhere really, but we happen to be talking about it in the context of Kubernetes. So, I almost forgot. You know how sometimes they say there's going to be a quiz at the end? Well, literally, there will be a quiz at the end. And I have a prize for you if you win the quiz. Look, it's a very small prize, but it's something. And so if you beat everybody else, you'll get something from our quiz at the end. It'll be fun. So, let's go into lesson number 1. Understand why. So, sometimes, unfortunately, we're like, I'm going to have this new technology. Why do you want to do it? Because Google is doing it, so we should also do that thing. Or, you know, that company over there, they're doing this thing, so we should do that thing too. Like, is there any other reasons? Like, well, yes, there's probably other reasons. So the first lesson is think about those reasons, because that will help you measure if this thing was successful. So for us, and obviously this will be different for where you happen to sit, our reasons were faster deployments, and particularly with zero downtime. Increased stability for our environments, that if you lose a server, that's not the end of the world, things keep going on. More production-like environments. It's hard if you're kind of hand-building bits and pieces here and there to make them all the same. And greater end-to-end control. Now, what do I mean by end-to-end control? And really, does Kubernetes do that? So, let me introduce you to a thing called cron. So my question for you today is, do you cron? Has anyone croned before? There's a few croners. Great. I mean, it's pretty straightforward, right? You go, I would like to have this job run. This is like a command to run 5 days a week and run a script. Super easy. That's if you don't work at a large enterprise. It's super easy. We don't use cron because that's too simple. We use a server scheduling tool, which I'm not going to name, but if I had used Rundeck, I think it would be better. So it's not Rundeck. Let me explain that one to you. So John's friend Damon, here's Rundeck, it's great. But what you should not do is use a technology and divvy up that technology across 6 different teams in order to make one thing happen. So this is I'll explain this to you. This is my summary of the process for setting up, so that the goal, this job needs to run on 5 servers every morning at 2 a.m. That's the goal. To achieve that goal in our organization, and fortunately, this organization does not exist anymore. This is last year sometime, early last year. But at the time, this is all genuine 100%. So you have these different teams, I'm not naming them, they're just different teams. And you can send the form, you fill out a form to engage them, or you send them an email, or you phone call, or maybe have a Skype conversation, right? So that's what we've got formed up here. And we're starting this process, we get so frustrated with it that, see this big gap at the end of my chart? We just kind of give up for a while. We're like, this is too hard. We don't want to run things on our servers anymore. So there's 2 months wasted trying to get us 5 servers to run a job. That's the next 2 months of the same process. And so for the next 2 months, we have to do things like, do I have a charge code? And so if you've worked in a large enterprise, these are all terrible things that you'll be familiar with. Do I have some kind of project management person assigned to this? And do I have all kinds of issues that have nothing to do with technology going through this process? So we get to the end of this. This is what happens. There's 2 phone calls, because I can tell you what, these teams do not like to phone each other. Phones are not their thing. There's 4 different forms that you fill in to engage with people. There's 17 conversations on Skype. There's 106 emails. And you're already smart, because you see at the end, right? 62 business days. I'm not even counting weekends. I don't even count the Christmas break. Not even counted. 62 business days. And not a single server at this point has been completed. Not even half of a server. And to be fair, we did change our requirements during this process. We said we don't want 5 servers, we want 9 servers. So I know, part of it's my fault. But this is what happens, and so this particular example, because I did another one and we were like, oh, that was not a good example because what you're describing is hard. I'm like, well, how about this example? Because running a job at 2 in the morning, not hard. It's like, okay, now we need to change something. So using this particular example, there's a lot of people that have been nodding to me that these things need to change. And fortunately, this particular, and if you've got data in a spreadsheet, turn it into a nice picture, and then your managers will understand what you're talking about, and then they'll agree, oh, actually, this is not right, we'll change this. And this is the why, right? You have a request, it goes to a pool of people, eventually it gets to someone that actually looks at it, and then what happens if it's not quite right, and it goes through again and again, and blah, blah, blah. Eventually it comes out the other end, maybe at some point with what you want. And the more people in the way, the more teams in the way of here to here, so it's kind of like the being able to map value through your system. The more teams in that process to get one thing done, the longer it takes. So that is actually a motivation for us behind Kubernetes, because I can get to a developer, I say, you just do everything you want to into this container, and then I'm going to build a system that automatically helps push that through. You don't need to talk to people about that thing, it's going to be automatic. So at the same time, and this is not just a technology problem, this is also a cultural problem, that we have to talk to teams and say, look, we have a new technology, you're not the gatekeeper anymore, your job is to build automation. And if you want to audit our system, go to the logs, we'll make you a special audit thing here, you can look at that anytime you want. But don't stop us and have meetings about having to approve things. We can have that, but we're going to automate it. Alright, so that was lesson number 1, it's a long lesson. Lesson number 2, you need some allies. You need people on your side that are willing to fight for this new thing. Things that are new and exciting in technology organizations that are big and clearly complex as ours, you do not have success without some good allies on your side. So these are my 2 that we had, and I could name others, but these are the 2 we're naming today. Julian is our enterprise architect. He was kind of the ops person in this particular setup. He helped us with all the teams that normally build these things, and he helped us solve problems. So from the very first day we thought, let's try and do this, and to the very last day when we went live, he was with us the whole time. So he wasn't like, I've drawn 5 boxes, my architecture is done. And I've drawn many lines between those boxes. So it's like, my architecting is complete here. No, he was actually with us and helping us and working through problems as they came all the way through. The other person, his name is Brendan Redford. He's our dev person, and if you want to know lots of technical things, I've got Brendan's email at the end, because he's the dev of all devs and can answer you many technical questions, which is beyond my capability even. And so he's the one that really helped us, because just because you've got a new system, if we wanted to move things across our apps, it's not just to pick it up and drop it over here and it magically works. For some things we needed new libraries, new security updates, whatever we needed, and you need developers to do the work for you. And so he was that voice helping those things happen. So that was great. Now, onto the technical side of things. Guess what? Containers. They're not little virtual servers. Because when they talk to you, and let me explain a little bit about containers. And so people talk about having a virtualized server, and that's pretty easy, because here's a server, and I virtualize that server, and I can run multiple servers. And then they talk about containers, they're like, oh, this layer kind of disappears, and then you have lots of little containers. And that kind of looks like you're going into big server, lots of servers, lots of little servers. And that's not really how you should be thinking about containers. They're a different thing from having a little server. So containers, and look, if you do servers well, actually it should look a lot like this anyway. But particularly for containers, they should be immutable. You never ever change the container. You don't jump in and go, oh, it's not working well, let me SSH into this container and I will fix it. No, don't do that, please. You get your image, you find something wrong, you change your image, you redeploy it, and now you have a new container running. Anytime that you need a change, you change it here, it goes through a cycle, gets validated, and then it pops out and you deploy the new thing. Always deploy the new thing. And so there's no old things running in your system, always new. Now, the other one is, these are new words for you today perhaps, immutable, and ephemeral. So ephemeral means that containers can be stopped and can be destroyed, they can be replaced at any point in time. So if you have this thing that's extremely stateful, that says I'm halfway through a process and it gets destroyed, and if that's bad for you, then that thing is bad for a container. Do not put that in a container. So that's why we talk about things like RESTful services, the things that can do work and send it in and out, and particularly things like microservices, perfect for containers. And look, we're a large enterprise that yes, we do run Java, and it's not quite microservices, but I have 27 of them, so they're much smaller than a massive monolithic thing. There's lots of little ones, and they do reasonably separated things. So I won't go as far as microservice, but we have services. And you will need that if you like to jump into a container. So, now, if I'm telling you you must build new images every single thing that you do, if you misspell something, rebuild an image, obviously you would like a pipeline that's very, very fast, because you don't want to wait for 2 hours every time you do something. And so you need continuous integration pipeline. It's automatic. I'm not going to explain config maps. You can Google that if you don't know what that is. But you'll need to build images in config maps. I finally think about Bootstrap script that runs on launch. Liveliness and readiness are two concepts that may be new for you in the world of containers. Liveliness just means that, hey, it's running, and readiness means that it can accept traffic. So you need to think about how to approach those, how you're going to make that work. Lesson 4. Look, this is just really a little note. This YouTube video goes for 50 minutes. I'm not going to explain it now. Key things to be aware of. If you are planning to run Java in a container, and you've got anything that's less than Java 10, you really need to think about how you're going to solve for the fact that your JVM will be in a constrained space in a container, but it can see all of the memory and all of the compute on that node. And so you can imagine the container's like, oh great, I can use 2 gig of RAM. And then Kubernetes sees it try to take 2 gig and says, no, you must use 1, and terminates it, and it starts again. Now, some people think this is a great feature. Oh, what a wonderful feature. Because if it goes too much memory, it just restarts it, and we start it again. And that's solved, problem solved. Then they come back a month later, and there's like, I wonder why this is restarted 500 times. And so you really should, you don't have to, because it does restart automatically, but I'm suggesting maybe you should think about that and plan ahead. Check out YouTube. Always learning. This is, so ANZ is one of our values, always learning, which is good, because this is the first time that we did logging. You don't need to read this all, but basically every yellow box is something bad that we did wrong. So when we very first set up logging, it wasn't great, and there was all kinds of issues with throughput and back pressure, and the logs, not most of them made it through, not all of them, and if you work in a bank, we really want all the logs. It's not 90% of the logs, we're really going for 100% is what we're shooting for. So our report card was, needs improvement. See me after class. It wasn't that great, but 2.0. So this is the gold star version. I'm not going to explain the tech behind this, but the key part for us was we used Fluentbit. We actually pushed up some changes to Fluentbit, we wrote some additions to it and submitted them, and changed the way that we were looking at our logs, and then we're able to fix this up. The lesson really though is that you need to plan for logging. Logging doesn't just magically happen, it won't be automatic. You need to think about it and have some kind of strategy set up for how log will arrive wherever you need them, and for us we're talking about Splunk, but I'm sure you have some log aggregation method in your company, and you need to figure out how you're going to get them there and how they're going to arrive, and you need to test that thing, because we were going a little bit fast with this, and this is our post-production live problem. So in production we were like, it's a few logs you're missing, and then we're like, well, we should really fix that really quickly, and we looked at the solution and put a fix in. But fortunately for us, lesson number 6 did help us. Because lesson number 6 is, Yes, one does not simply deploy everything to Kubernetes and then hope for the best. What we actually did is we deployed, I think, about 2 services. So we went full cycle through, the 2 services went live, and look, when you just have 2 services logging, it's really not that bad and you don't lose very much. But if we had deployed, like, we had more things ready, if we just deployed them all and went live, then it would be much worse and much harder to fix. And so whatever you do, whatever you choose, and this is reasonably obvious, but plan for this anyway, is there's a lot of new things you're going to learn in this ecosystem that you didn't know before. And you will only know them by doing it. So logging was the surprise one for us, but for whatever you're doing, networking can be funny on communities. There's lots of other little bits and pieces. Or even training our support teams and helping them understand how this stuff works. If you do that one little piece at a time, it's way easier. Which brings us next lesson 7. Similar idea, right? That add features over time. So we started, so namespace is a way to describe a particular area that is kind of like a project maybe, and that you can have resources inside a namespace. And so we pretty much just did a one-for-one copy of what we had in the old world. We had an environment, and the new world we had a new namespace. Then after that, we started to use more features from Kubernetes. So there's a thing where you can put a label on these pods, and you'll already have some labels there just by deploying them. We added some new set of labels that said, hey, this is copy 1 in this environment, this is like copy 2 of an environment, and that allows you to do canary deployments. Where you're like, yeah, I'm going to send 10% load here or 20%, and just by having a new feature, by sticking labels on things. So it's pretty cool. The next thing we did was the continuous integration service that we'll have a bit of a look at because it's a bit of a tech conference. Maybe we should talk a little bit of tech for you. And not just like find friends and be nice. So there's this thing called per build container Bamboo. So if you happen to be using Bamboo, you can use this thing. But if you get rid of the Bamboo, I'm sure you can do this with Jenkins. There's lots of other ways to get about doing this. So what this is that we have a pod. So a pod is a collection of containers. So inside this space, we run an agent. And that agent has another container sitting next to it, which is our D container for dependencies. And then another one sitting next to it, which is Docker and Docker. So what this means is all those things together allow you to have a build job. So you can build an artifact, in this case a Docker image. Or for us it was, we start out with Java, so you build a raw file, a EAR file, whatever you want to use. We run unit tests and we do a Docker build and a tag and we push that image out. So the magic thing about separating this stuff out is that, hey, I can use the same approach and I want to build Go tomorrow. I don't want to build Java for the rest of my life. So, because Go's cool, right? So I'm going to build some Go stuff, but it's different dependencies, different setup. I can build a new container that's just for that. I don't need to mess around and try and do a Java/Go container. I just have a separate one. And then if Docker gets upgraded, that's a separate container also. So we separate these things out. So I can use the same agent that does the building and that kind of pipelining stuff. I use a different dependency based on whatever I'm building. And I've got, in this case, Docker and Docker also separated. And I can do whatever I need to do in that space. And so after that, you know what I can also do with that agent? I can spin up a whole new namespace. And I can create a new system test environment. And so after it passes the first phases, I bring up a whole end-to-end with dependencies environment. And I simulate whatever I need to. And then if that passes, that's when I start doing code scanning and security scans and lots of other things like that. Pen testing, it's all automatable now. And then if that all passes, then I have lots of logs, because logs work now, thank goodness. And then I destroy everything, it all goes, boom, gone. So what happens is, if I want to do a build, great. But if I want to do 5, 10, 20 builds, all you need is more compute. And you can do as many builds as you want, and they all happen at exactly the same time. There's no queues, no queuing of things. It just all gets built, it all gets built right now. And if you want to do different builds of different things, different apps, doesn't matter what you do, it can all be built, and it's all separated out, and so it all happens at the same time. So It's a bit magical. We've been having fun with it. So we've got like maybe 5 out of 27 working this way, and we're working through the others. And you know, what the technology is a bit complex and getting it to work and that kind of thing, but what's way more complex is getting the developers to fix their unit tests. You dirty developers. So once those unit tests all work, we'll be going through it. So, final lesson. So quickly. Lesson 8. So this is, because some of you will be sitting here going, this guy's been saying Kubernetes a lot, he says containers a lot, and I've got no idea what he's talking about. Fair enough, you may not have heard of these things before. Ta-da! This is the Kubernetes comic. Just type Kubernetes comic. The first thing will come up is an ad from AWS to use their containers. Fine, you can do that if you want to. But the next thing that will come up will be the ad for the Kubernetes, not the ad, the actual link to the Kubernetes comic. And it's actually a really good way to learn about these concepts that I'm talking about. So, yes, it is a comic, but the concepts it goes over and the way it presents it is actually a really easy to go through way to learn about these things. And you'll help you kind of get a hold of some of these concepts and how they work together, I think, quite quickly. So I recommend that to yourself if you're interested, or just for people that you're trying to explain containers and why they're important. I actually recommend have a look at the comic and go through it. It's quite good. You can learn about Athena, the goddess of containers. But the other half of this one, sorry. The other half of this one is the training and the education. So sometimes we implement things and we're like, have you told anyone how this works and have you documented this? And like, yes, I've written documentation and they can go read the README file. It's right there in Git. It's a README file, it's done. I'm like, well, if you're in my team, that's not our definition of done. So our definition of done involves, we've been creating videos, and so we have a video walkthrough where, because I mean, you can do a session and have people come along, but what happens to the developer that joins next week? How do they learn about it? You run another session for that one person? So what we've done is we create videos, we do a walkthrough of these deployments, and then we talk about, hey, this is how you do a deployment, and this is the steps. So you can kind of watch it, and then at least gives you a little bit of knowledge, and so you're familiar with at least some of the words we use when you come and talk to us about, hey, I need to do this for real, can you help me out? So it helps, because you're not going to watch a video and go, now I'm an expert, but if you watch the video, it helps to get you some of the way there. When you talk to us, everything makes more sense. We're talking the same language. The next thing we do is that we have, every now and again, we have a hands-on tutorial session, because we don't just operate in Melbourne. We're in Melbourne and Sydney and in Bengaluru in India or in Chengdu in China. So we have all these people that are on a phone call, they're also on Slack, and then we have a kind of run through a session where one of my team will make a broken CI build that won't work. And then we give that same build to everybody. We say, all right, now you need to make this thing work. What do you need to do? And we talk through how you would troubleshoot that, which things to look for, how would you fix this thing? Because most of you will know it's not the running that teaches you anything about automation, because it just runs. It's really how do you fix it when it's broken that teaches you a lot about how it works. And so because we're in different sites, we have people can post on Slack, oh, this is the error that's coming up. And because people come up and they find the strangest things during these sessions, but because we're all there and we can talk through it and we can see it, that we can all work through these issues together. And so everybody kind of gets to close to the same level at once. So if you're going through this kind of thing, think about what are you going to do to train people and catch them up to where you are. Now, finally, what are the results? So, and look, this is still super common, but if you work at a large company, you might do the old 18-hour Saturday night where you kind of start very in the afternoon maybe, and you go to Sunday morning. You're like, yes, I have already delivered another thing into production. And like and some people like those things, like, yeah, we're all getting together and we're going to get some takeaway and deploy some software. We're like, no, I'd rather be at home. So now we do deployments. It takes an hour, but that's during business hours, and we verify and check it and all those kinds of things. And that's pretty good. It's a lot better than on a weekend. Then there's other things like, because people would change in a test environment things so much, we would always have like, oh, it's a planned outage, it's fine. I'm like, no, it's still offline. Just because you plan it doesn't make it better. And so even though we have very meticulously planned outages, they're still outages. And so those have gone away now. And even if we do, because it's not a perfect world, things crash. But in the new world, at least in Kubernetes, that thing crashes, not the whole thing crashing. So it's better. New environments, that just take ages, and now they're faster. And then the release time, and this is not really to do with Kubernetes, right? This is a lot of people lining up a lot of continuous delivery concepts to make this actually happen. But we went from an average of 36 weeks, and we're now kind of down to an average of 6 weeks. But to me, the most important thing is that we had a security issue we found. We pushed that through a full cycle in 1 day. And to me, that's pretty important, because you need to be able to, because we have things we're working on, we're like, yeah, we don't have code that's older than a few weeks, and that's way better, because we used to be a few months. But if you have a really important thing that needs to go through, we have a system that allows that same day to go through. And so it's the people that need to catch up with where we're at. And that's a harder question. So, I hope you've taken that all in, because it's time for a quiz. Ladies and gentlemen, please reach for your phones. You don't have to, but it'd be more fun if you actually joined in. So let me do an alt-tab. Scupper. Yes. This is the information. You need to go to www.menti.com, and you type in a code, which is 56711. And once you've done that, and you've arrived, you click the little heart, and it makes little heart images. There's more. But for now, that's where we're getting to. Once we have a goodly number of people, we'll start the quiz. There are, how many questions did I put in? Like 6. But a bonus question at the end. So I hope you've been listening. What will happen is, it'll ask you to register. You can type in a name. Try not to type in a really, really long name, because I'm just going to start the quiz, so you'll be still typing. Let's get ready to rumble. All right, so I do ask that if you end up being the #1 person, if you can take a screenshot with your phone, then that'll help me to know that you're #1. Because it'll be like or put your actual name, that'll also help me. Either way. But if you want to be Shiny Pony 5, then screenshot. Then you're like, I'm Shiny Pony 5, great. So, let's go. We're going to start question number 1. I think 97 is good. Alright, so this is the get ready phase. Which month did ANZ go live with Kubernetes in production? September 2016, October 2017, November 2017, or November 2018. We've got 5 seconds, come on people! Yes, votes are in. Who did November 2018? Come on people. That hasn't happened yet. I didn't tell you for question 1, I'll tell you for question 2. The faster you are, the more points you get. But you have to be right. Okay. Alright, question number 2 is coming. Yes, go Wi-Fi. Players are here. Let's start the question. True or false, a Kubernetes pod will always have a single container. True or false? What does this say? Internet connection, that's fine. We'll survive. 3, 2, 1. What happened? Come on. Yes! It's still working. False. Because I showed you. There was 3 containers in there. Next question. Don't worry, you can make it up. There's still more questions to go. As long as the Wi-Fi stays with us. Stay with us, Wi-Fi. How many emails did teams send while trying to schedule server jobs? Remember, and it was some amount of emails that they sent. 67. 99. I have 99 emails, but yours isn't one of them. Or 106. Which one is it? Dun, 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 dun. Oh! Alright, people are getting into clue 1 to this. Except for those other people. Sorry, other people. Leaderboard. Ooh, that's close. People are good at pressing things. All right, so Frisky Puppy, you're #1 right now. Well done. Screenshot. So, lesson 3, we learned that containers are, what are they? Awesome, great. No, fungible and reliable. Are they mutable and ephemeral? Are they mutable and derivable? Are they immutable? Those are your options. Select one. We'll see who wins. Whose cuisine will reign supreme? Oh no, that's the different show. Yes, immutable and ephemeral is correct. You guys are getting really good at this. I'm going to have to ask harder questions. It's too late, I've already done this. Start question 5. Alright, lesson 4. What should you be careful about putting in containers? Everyone knows this. I'm going to press it really fast. You're right. Is it a monolithic system? Is that what you're putting? Or is it Java? Or is it microservices? Or small animals? I know, someone is going to click it for sure. How many? 2 people. Why would you put small animals in containers, people? That's not nice. Container, the leaderboard again. How many have you got? I think I got 2 left. Ooh, Frisky Puppy, fast on the buttons. Oh, some movement. Alright, who's Mike Berry's not doing this? Because that's me. ANZ On Demand CI service is built to run in. So, Red Hat OpenShift, Rancher, Docker Data Center, IBM Bluemix. I mean, that's options. There's different ways to do it. If there's anyone from IBM, sorry, but it's pretty bad. Yes, well done. I think last question. Leaderboard, okay. Leaderboard. Dun, 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 dun. Ooh, movement in the leaderboard. No, still. There's movement, but Frisky Puppy is still #1. Here we go. Last question, I'm pretty sure. Yes, this is the last one. Which mythical creature the following companies sometimes referred to as, are they DevOps dragons, DevOps chupacabras, or limitless, or DevOps chupacabras? Yes, I did not talk about that in my presentation. That's why it's a bonus question. And people know the answer to that too, pretty much. So, let us show the winner. I think DevOps chupacabras would be good though. Maybe we should try and push that. Hashtag DevOps chupacabra. Oh, still #1. 6,434 imaginary points. Well done, Frisky Puppy. You can see me at lunchtime. And you need to take... Alright, anyone's hand up? Alright, see me at lunch, and you will get a very small prize. It's better than a sticker. It's not a small prize. It's not a sticker. And you for winning. Well done. That's it. Thank you, everyone.